we have discussed some important definitions with respect to algorithm. We have discussed the definition of an algorithm and what do you mean by problem. Then what are the important properties of algorithm? Then how do you analyze an algorithm? Given an algorithm, how do you analyze an algorithm? That is, we have discussed something about space efficiency and the time efficiency.
Time efficiency.
Now let us, and also we discussed the basic operation. Whenever I want to find out the time efficiency of an algorithm, we need to identify the most important operation in an algorithm. That operation is called as the basic operation. The basic operation is the one where it takes more amount of time in an algorithm. Given an algorithm, finding the basic operation is very easy. Normally it is situated in the innermost for loop. For example, in this program, if a of j greater than a of j plus 1 is the basic operation, then it assume that the outermost for loop will be executed n, neglecting the constant, and the innermost for loop will be executed n, neglecting the constant 2 minus I. The total amount of time the basic operation will be executed n square. Assume that basic operation takes 1 unit of time. 1 into n square is n square. Like that, if you are in a position to identify the basic operation, we can easily find out the time efficiency of an algorithm. That's what this formula says. T of n is approximately equal to b times c of what n, where b is the execution time for the basic operation in an algorithm. That is, for example, in the bubble sort algorithm, assume that the comparison operation takes 1 unit of time, b is equal to 1. The total number of times the comparison operation, that is, if a of j greater than a of j plus 1 is executed, is n square. 1 into n square is n square. That's why time complexity of the bubble sort algorithm is what? T of n is what? N square. Now let us, once we know the meaning of the basic operation, let us concentrate on order of growth. See, your algorithms work very beautifully for smaller value of n, but as the value of n increases, the algorithms are very slow. Let us take one example. Assume that in your village or in city, they are conducting ragi ball eating competition. Normally, they will be given, first initially they will give 2 ragi balls, then 5 ragi balls, then 10 ragi balls. As the number of ragi balls is increased, then the time taken by the person to eat the ragi balls also increases. Then whoever person who completes the task of eating the ragi ball fast, he will be awarded the prize. In the similar way, when the algorithms works very fast for smaller value of n, but as the value of n increases, they behaves very slowly. This change in the behavior of an algorithm as the value of n increases, this term is called as what? An order of growth. See, normally the order of growth is normally determined for larger value of n. See, why we are going to determine the order of growth for larger value of n? In the ragi ball eating competition, if there is only one ragi ball, we are not going to conduct the ragi ball eating competition for only one ragi ball, where n is the input. Here n stands for what? Number of ragi balls. But we are interested in how exactly your algorithm behaves as the value of n tends to infinity. You take in our day-to-day life, normally we encounter huge amount of data. For example, I want to sort all the Airtel customers according to their name. Then I should use some sorting algorithms. If I take Mysore or Bangalore in a particular region, lakhs of customers will be there. Then n is the number of customers. Then we are going to apply some sorting algorithm. Based on that, it is going to sort. Normally, if the problem is small, we can solve by our hand. But if the problem is large, we are going to use the best algorithm. For example, if I want to sort two numbers, then I don't require any algorithm. But if I want to sort 1,000 numbers or 10,000 numbers or 20,000 numbers, then only we need to select the most efficient algorithm. If I want to select the most efficient algorithm, then I should know the order of growth of that algorithm. Finally, what is the conclusion of order of growth is how exactly our algorithm behaves as the value of n increases, whether it it performs well or it may not perform well. That based on the efficiency of an algorithm. See, this order of growth is normally determined for larger value of n. Right. The order of growth is normally determined for larger value of n, because the first reason is the behavior of an algorithm changes as the value of n increases. For example, in the Euclid's algorithm or in the school level algorithm, if the input is small, for example, if I want to find out the GCD of only 2-digit numbers, your school level algorithm and as well as Euclid's algorithm performs better. But if I want to find out the GCD of 100-digit number, m is an 100-digit as well as n is 100-digit, your Euclid's algorithm performs better when compared to what the school level algorithm. That is, the behavior of an algorithm changes as the value of n increases. And second point, in real-time applications, we normally encounter large value of n. If you take in our day-to-day life, we won't solve any problem with respect to smaller value of n. Always we are interested as the value of n tends to infinity. N tends to infinity means as the value of as the value of n increases to a large value. See, for example, assume that there is one problem A. I want to solve one problem A. The order of growth of solving the problem A by using two algorithms. For example, one algorithm takes n, that is n amount of time. The running time of the algorithm is the time efficiency of one algorithm is linear. Linear in the sense it is n. Another algorithm takes n square amount of time. N square means quadratic. If, for example, I want to solve the problem A. If I want to solve the problem A, the first algorithm takes the linear amount of time. The second algorithm to solve the same problem takes the quadratic amount of time. I can say that the first algorithm is better than the second algorithm. If you take for example, if you take school level algorithm and another one is the school level, another one is the Euclid's algorithm. Assume that the school level algorithm takes quadratic amount of time, then your Euclid's algorithm takes the linear amount of time. I can say that your Euclid's algorithm is better than what your school level algorithm. This table shows the various order of growths. See, first, this shows the n, the value of n. The n is nothing but number of inputs. N is 1, n is 2, n is 4, n is 8, n is 6, and n is 32. See, these are the different order of growth. These are the different running times of different algorithms. One is log n, another one is n log n, n square, n cube, 2 to the power of n, and n factorial. See, for example, the time efficiency of the bubble sort is n square. Similarly, if you take the matrix multiplication, since there are three loops, the time efficiency of the matrix multiplication is n cube. See, for example, n is 1, log of 1 is 0, n is 1, n log n, that is 1 into 0 is 0, n square is 1, n cube is 1, 2 to the power of 1 is 1. Then similarly 1 factorial is what? 1. If we take n is equal to 2, then the second row shows what is the order of growth of all these functions, that is log n when the value of n is 2, all of you can observe carefully, as n increases, order of growth also increases. Then any algorithm which is having this 2 to the power of n and n factorial will take more amount of time. For example, let us take, assume that arrange I want to arrange two numbers. For example, AB. N factorial is the permutation problem. The maximum n is 2 means the maximum arrangements are AB and BA. Similarly, n is equal to 4 means there are totally 4 factorial, 24 arrangement. Similarly, if I give 8 alphabets and if I ask you to arrange, then that is 40,320. Like that, even your calculator will also takes more amount of time, especially in factorial. Any algorithm which is having n factorial as the time complexity, it will be the most slowest algorithm. Any algorithm with the log n time complexity is the somewhat the fastest algorithm. This is about the order of growth. Order of growth is the one how exactly your algorithm behaves as the value of n increases. See, this table shows the order of growths or the running time of different algorithm. For example, assume that I have only one statement in a program, main x is equal to 1. How many times that statement will be executed? Only one time.
Only one time.
That's why the time complexity of that algorithm is what? 1. We will call that as constant running time. For example, in a binary search, the time efficiency is log n. We call that as the time efficiency of binary search is logarithmic in nature. Similarly, with respect to linear search, the time complexity is linear. I will explain all those things. If you take the bubble sort, what is the time complexity? How many loops are there? 2 loops. That's why the time complexity is what? N square. That's why we'll say the time complexity of bubble sort is quadratic in nature. Similarly, all of you might have seen in the last semester Tower of Hanai problem. In the Tower of Hanai problem, if there are n disks, how many disk moments will be there? 2 to the power of n. Similarly, if I want to find out the permutation of a set means, for example, I will give two numbers, then what are the possible permutations? 1, 2, 2, 1. Similarly, 3 numbers, 6 permutations. 4 numbers, 24 permutations. We will call that permutation problem as the time complexity of the permutation problem is factorial in nature. These are the some of the, in this subject normally we are going to come across all these time efficiencies, 1 log n, n log n. As the value of n increases, the order of growth in all these algorithms also increases. See, this is about the order of growth. You understood what do you mean by order of growth? You understood what do you mean by the order of growth with this example. Now, once we know the order of growth, now let us concentrate on the worst case, best case, another one is the average case. Once we know the order of growth, let us concentrate on the worst case, best case, another one is the average case. What do you mean by the worst case? What do you mean by the best case? Another one is the average case. See, for example, I told as the value of n increases, your time efficiency also increases. It is not true for all the algorithms. Some of the algorithms depends on the type of the input. Let us see with this example. For example, assume that I want to search an element by using a linear search. There are 4 elements, a of 0, a of 1, a of 2 and a of 3. Then the total number of elements are 4. Now, this is the small code I have written on the right hand side to explain the logic of this linear search. See, if key equal to a of I, printf success, exit 0, printf successful sir. If I am not able to find out the key element, then I am saying unsuccessful search. Why do you call it as a linear search? Because first I compare the first element, then I compare the second element, then I compare the third element, then I compare the fourth element. See, for example, in our library, assume that I want to search the C programming textbook. Then what happens? Assume that the C programming textbook may present in the first rack, first row, or C programming textbook may present on the last rack, last row. One more possibility is the C programming textbook may not at all present. These are the three possibilities. If the C programming textbook is present in the first row, first rack, we are going to compare only one comparisons to. Then if the C programming textbook is present in the last row, last rack, then we are going to, if there are 1,000 books, then we are going to do 1,000 comparisons. If the C programming books is not at all present, still we are going to compare all the racks, assuming that there are 1,000 books. We are going to compare how many books? 1,000 books. Similarly, if the C programming is present somewhere in the middle of the rack, then we are going to compare, that is 1,000 by 2, approximately 500 comparisons. So let us take with an example. Assume that the key is 20. I want to search the key. Key is your textbook here. Key is your what? The textbook. I want to search in all these 4 array elements. The value of I will be 0. 0 is less than or equal to 3. The condition is true. If key equal to a of 0, what is the value of key? 20. 20 equal to 20. The condition is true. That's why the output is what? Successful search. Then the number of comparisons is equal to how much? 1. The case number 1. Let us take case number 2. In the case number 2, assume that the key value is 30 and these are the 4 array elements. First, I is equal to 0. 0 is less than or equal to 3. The condition is true. First, I am going to check if key equal to a of 0. That is 30. Key is what? 30. A of 0 is what? 20. 30 is equal to 20. The condition is false. Then I will be incremented to 1. 1 is less than or equal to 3. Yes, the condition is true. If key equal to a of 1, what is the value of key? 30. 30 is equal to 20. The condition is false. Then I will be incremented to 2. 2 is less than or equal to 3. Yes, the condition is true. Then check key equal to a of 2. Yes, the condition is false because 30 is equal to the condition is false. Then I will be incremented to 3. I will be incremented to 3. 3 is less than or equal to 3. Check key is equal to a of 3. Yes, because 30 is equal to 30. Then it is the output we are going to get what? Successful search. Then I am putting here exit 0. Exit 0 means immediately after printing the success, I am going to come out of the program. Now total number of comparisons: 1, 2, 3, 4. Totally how many comparisons? 4 comparisons. When the key is 30. When the key is 20, how many comparisons? 1, because I'm able to find out the key in the first location. Now let us go for the case 3. Case 3, assume that the key is 60. Assume that the key is 60. First, I is equal to 0. Then key equal to a of 0. 60 equal to 20. The condition is false. I will be incremented to 1. Key equal to a of 1. 60 is equal to 10. The condition is false. I is equal to 2. Key equal to a of 2. The condition is false. Then I will be incremented to 3. 3 is less than or equal to 3. Key equal to a of 3. The condition is false. 60 equal to 30. Then I will be incremented to 4. 4 is not less than or equal to 3. The condition is false. That's why it is going to print the statement after the for loop. Which is the statement after the for loop? Unsuccessful search. But even though the element is not present in the array, we are going to do how many comparisons? 4 comparisons. 4 comparisons. First we have seen the case 1, we have done 1 comparison. Case 2, we have done 4 comparisons. Let us go for case 3. In the case 3, we have done 4 comparisons. Let us go for case 4. Assume that key is 10. Key is 10 means the key is somewhere in the middle, not the first element, neither the first element nor the last element. somewhere in the middle. See, first key is equal to 10, I is equal to 0. If key equal to a of 0, the condition is false. If 10 equal to 20, the condition is false. Then I will be incremented to 1. Equal to 3. Key equal to a of 1. It is true. 10 is equal to 10. Then I will exit from the loop, thereby printing the statement called as what? Successful search. The number of comparisons is equal to what? 2. See, after studying all these logics, we will call the case 1 as the best case. Best case in the sense, see, the number of comparisons. See, if the in the linear search, if the element is present in the first location, we are going to come. I am going to take only one comparison. This type of searching or this type of finding the time complexity is called as what? The best case. Okay, always the best case in the sense, always your algorithm takes less amount of time in the best case. See, case 2 and case 4, case 2 and case 3 are called as the worst case. Worst case in the sense, your algorithm will take the maximum amount of time to solve the problem. See, for example, in the case 2, if key is 30, the number of even though the element may present, the element may not at all present, we are going to do 4 comparisons. In the, that is, key is 30, still we are doing the 4 comparisons. Then key is 60, 60 is not present. I can't directly say that the key is present. Still I need to do 4 comparisons. That's why this case 2 and case 3 is called as what? The worst case. That is, if there are 4 elements in an array, then I am going the worst case. I am going to do 4 comparisons. If there are 4 elements in an array, in the best case, I am going to do only 1 comparisons. Case 4 is an example for the average case. Average case is the more than the best case, then the less than the worst case. See, let us take here, totally 5 elements are there, 4 elements are there, 4 by 2. How many comparisons? Approximately 2 comparisons. This is about the best case, worst case, and the average case. This is very much essential to know the further concept. Best case in the sense, your algorithm will take the least amount of time to perform an operation. The worst case in the sense, your algorithm will take the at most in the more amount of time uh, for performing an operation. Average case in the sense, it is more than the best case and less than the worst case. Always we say that always prefer for the always go for the best and prepare for the worst. We are interested in worst case because if I know the maximum, worst case is the maximum time complexity, then best case is the minimum time complexity, then average case is the as usual. Always we're interested in the worst case time complexity because once you know the maximum time complexity, still there is a possibility of reducing the time efficiency of an algorithm. I think all of you understood what I mean by the worst case, best case. Another one is the average case. Now let us see the let us see in detail the meaning of the best case, worst case, and the average case. Right.